So let us look at this mathematical modeling. What is the first step? Define the sample space of the random experiment. Perform the random experiment and find the outcomes. Once you know the outcomes, you can define the sample space. The second one is define the events. On the sample space S. Then find the probabilities the probability of occurrence of these events. Probabilities means probability of occurrence of the events that we did. Probabilities of these events. And then verify the three axioms. Verify the axioms of probability. Actually, in the first step, though we have written a single statement, what we are doing, performing the experiment, finding the outcomes, and then defining the samples. Let us consider a simple example. A pair dice. A pair dice. Die. Dice is a plural. A pair die is thrown twice. A pair die is thrown twice. Mathematically model this experiment to find sum of the numbers that come up on the die. So what are the possible outcomes here? Possible outcomes. So let it be throwing of the die the first time, and here throwing of the die second time. So here, what are the possible outcomes in the first case? How you get up to 12? Only 6. What are the possible outcomes when you throw once? 6. If you throw again, you will get 6. So these are the numbers that can come up. Either of these 6 numbers can come up in the second trial, and either of these numbers can come up in the first trial. So here trial 1, this is trial 2. Then the sum of the numbers on the die. The number on the die is 1 in the first trial and 1 in the second trial also. Then the sum of the numbers is 2. If this is the case, it will be 3, 4, 5, 7. Here, you complete this. Here, how many possible outcomes we have? 6 into 6. Total possible outcomes is 36. Now find the probability of the sum of the numbers. That is, what is the probability of 2? Actually, 1 by actually probability of sum equivalent to 2. So in how many ways 2 can occur? Only one way. That is, the number on the first and second trial is 1, then only the sum will be 2. So therefore this will be 1 by 36. The probability of sum equivalent to 3. So when the, how many ways? 2 ways, see here. When the combination is 1 2 or 2 1, we are getting 3. So therefore it is 2 by 36. Similarly, you can probability of sum equivalent to 12 is again equivalent to 1 by C. Here we are not getting any negative number. First axiom is satisfied. Probability of a particular event is a non-negative number greater than or equivalent to 0. And if you add up all these, you will get 1. Is it right? So that is also satisfied. See these events 1 by 36 plus 2 by 36 and so on. You will get 1, so you will get 1. And the remaining 1. Is it satisfied? See, probability of getting a number, probability of getting the sum 6 or 8. What is the probability of sum equivalent to 6 or sum equivalent to 5? See, it is when the outcome is 6, 5 will not occur. The outcome is 5, 6 will not occur. That is, the sum is 6, 5, there is no chance of getting the sum 5. So therefore, these two are mutual exclusive. So probability of sum equivalent to 6 plus probability of sum equivalent to 6. So you can find that. So here, the third axiom is also set. So this is the way of mathematically modeling a particular random. So even though the complexity of the random experiment that we perform is increasing, the procedure is same to mathematically model the random experiment. Understood that?